Hey everyone, today we're going to talk about how to multiply polynomials that are considered special cases. Last time we talked about just multiplying two binomials. Today we're going to expand on that idea. Nothing really new, but looking for some patterns that will make it a little bit more efficient for certain types of problems. So with that said, our goal, special products of binomials, our objective, our goal is to be able to square a binomial. It's as simple as that. What does it mean to square a binomial? So remember, you're taking notes, you're putting on the right-hand side, you're putting your name at the top, you're putting your title, your objective, all the main notes, any examples, and then your summary. And then on the left-hand side, you're going to put all your practice problems, okay? So go ahead and write an essential question based on this objective, and then we'll go ahead and get started. So this is one that you're going to put on the left. It says simplify the following expression. This is something that you did as just a practice from before. So go ahead and pause the video, see what you come up with, and then when you're done, come back and compare what you did to what I did. So for number one, it says to simplify. So we have x minus 4 and then times 2x plus 2 minus 3x times x plus 5. Okay, and so we want to simplify this. So we want to multiply these binomials here. We want to distribute this negative 3x to this guy, and then we'll combine like terms afterwards. So the first thing I'm going to do is deal with this part, the x minus 4 and the 2x plus 2. And you remember the way we do that is that we separate the first term. So it says x times 2x plus 2, and then minus 4 times 2x plus 2. Okay? Then we distribute each one of those terms into the binomials here. So we end up with x times 2x is 2x squared, and then x times 2 is 2x. Then we'll distribute the negative 4 there, so that's going to be negative 8x and minus 8. Okay, so we have the multiplication of the two binomials here. And then I'm just going to carry this down so that we can see it right next to it where it belongs. So we have negative 3x times x plus 5, and we'll distribute that guy as well. And so we end up with negative 3x squared minus 15x. Then we'll combine like terms. So remember, when we combine like terms, we want terms that have the same exponents, the same value for the exponents, and the same bases. So we can see that the 2x squared and the negative 3x squared are like terms. So 2 of them and negative 3 of them makes negative 1 of them. So we'd say negative x squared. And then we have the 2x and the negative 8x and the negative 15x. Those all combine. So 2x minus 8x is negative 6x. And then minus 15x is going to be negative 21x. And then the negative 8 here is just a constant that we can't combine with anything else. There's no other constants here. And so this is the simplified expression all the way. It's written in standard form. Remember, standard form is the highest exponent first and then decreasing down to the constant. So it's in standard form, and it's as simplified as much as it can be. For number two, it says to solve this. So this is actually going back to 8th grade and Math 1 as review problems to solve equations. In the first problem here, we were just simplifying the expression, so we don't know what x is. There's no equal sign to solve. But here we have an equal sign, so we can actually calculate the value of x. So the first thing we're going to do is distribute that 2x, and so we end up with 7 plus 2x minus 10 equals 4 minus x minus 7 plus 3x. Then from there, we're going to go ahead and combine like terms. So on the left-hand side, the 2x is all by itself. So we're just going to carry that down. That says 2x. And then the 7 and the negative 10 are like terms. So 7 minus 10 is negative 3. And then on the other side, combining the x's, we have negative x and 3x there. So that's going to be a positive 2x. And then we have the 4 and the negative 7, which is going to turn into negative 3. Interesting. 2x minus 3 equals 2x minus 3. Notice one thing I didn't do is I did not combine these x's with this x. I did not combine these constants with these constants because they're on opposite sides of the equal sign. So we don't want to just combine them all. We have to actually move them over, do the opposite operation, okay, the inverse operation. The next step here is to get x by itself. So I'm going to move all the x's to one side. So I end up with, when I subtract 2x here, I actually end up with 2x minus 2x is 0. So I'm left with negative 3 equals negative 3. And so this problem is actually a good problem to discuss because there is no specific x value that produces a true equation here because it doesn't say x equals something, okay? The point is, because the left-hand side is exactly the same as the right-hand side, it really doesn't matter what x value you plug in, the equation will be true. And so we would say that x could be all real numbers. In other words, x is all real numbers. No matter what x you plug in, you will get this side equal to this side. It will not matter what x value you plug in. So let's see if I can come up with some examples that might be different. So x is all real numbers, or all real numbers are solutions. If you end up with something in the end of the equation where it just says x equals 5, well, that's your answer, x equals 5, okay? If you end up with something that is a false statement like this, negative 3 equals 4, there's no x's there. Negative 3 equals 4, well, negative 3 doesn't equal 4. If that's what you come up with, then you would say there is no solution. In other words, there is no x value that I can plug into the equation to make that equation true. But if you end up with an absolutely true statement, negative 3 equals negative 3, that's always true. And so therefore we say all real numbers. Okay, so those are just different ways you can get different answers there. All right, now with that said, let's go ahead and go on to what the real purpose is of this lesson. So here's just some more practice problems for you. X plus 8 times x plus 11, just multiplying binomials. So go ahead and pause the video, do these problems, and then come back and compare to what I do to see if you got it right. Okay. Again, this can be on the left-hand side. For number 1, we have x plus 8 times x plus 11. So remember, we write it, we expand this, if you would. We rewrite the first binomial to say x and then times x plus 11. And then we'd say plus 8 times x plus 11. And so then from there, we'll go ahead and distribute the x into both of those values, those terms. So we get x squared plus 11x. And then for the second one, we'd multiply the 8 into the two terms. So we'd end up with 8x plus 88. And then we'll combine like terms. There's only one term that has an x squared in it, so we'll carry that down. The 11x and the 8x can combine to make 19x. And the 88 is the only constant we have. So number 1 is x squared plus 19x plus 88. Okay. Number 2, I'm going to do in a different way. And it's okay if you didn't do it this way. It's perfectly all right. I just want you to see the different ways to multiply, okay? Now, the way we did it on number 1 is the way that I would really expect you to show your work because that's really what's going to benefit you in math in the future, okay? But there are different ways to multiply these things. So remember, this really means a rectangle of some sorts that is cut up into 4 pieces, okay? One piece this way and one piece that way, so we have 4 pieces. This length could be written as 4x minus 5, and then the height here can be rewritten as x minus 1. So we just take one binomial and carry it across, and one binomial and we'll carry it down. And then from there we multiply just like a multiplication chart, or like area, right? We find the area of each rectangle, or like a multiplication chart, x times 4x is what? However you see it. But x times 4x is 4x squared, okay? X times negative 5 is negative 5x. And then negative 1 times 4x is negative 4x. And then negative 1 times negative 5 is positive 5. And then we'll go ahead and combine like terms. We got a negative 5x and a negative 4x go together. And so our final answer here is going to be 4x squared minus 9x plus 5. So that is using an area model to help us solve or simplify that expression. Any way is fine. It's just this way is going to be more efficient for you in the future. So if you're comfortable with this way, that's great. What I would recommend is that you do it, you get the answer that you feel confident in, and then go back and practice it this way to make sure you're getting the same answer. But this is the goal eventually, okay? Like we did on number 1. So for number 3, I'm going to go ahead and do it like the goal, really what we want to have happen, I guess. So we're going to go ahead and rewrite this as x times x plus 10 minus 9 times x plus 10. And then we'll distribute that. So x times x and x times 10. We end up with x squared plus 10x. And then we'll distribute the other one, the negative 9. So negative 9 times x is negative 9x. And negative 9 times 10 is negative 90. And then we'll combine like terms. The x's are the only ones that we can combine. And so we end up with x squared plus 1x minus 90. And that is our answer for number 3. I'm going to go ahead and quickly just compare what I did earlier to make sure I did it right. Number 1 looks good. Number 2, this is a different way of multiplying binomials. And that's okay if you see it that way as well. That will work. And then number 3 is also x squared plus x minus 90. So we ended up doing all of those right. So let's go ahead and go on to the next slide. Now this is going to be on the right-hand side because these are notes, okay? The square of a binomial, okay? The square of binomial. And I want you to write this entire slide down for me, okay? The squaring of a binomial. Well, here's an example. You can write this down. Simplify x plus 5 squared. Now, if you stare at that for a second, my guess is that most of you will think, I know what to do. I know how to square numbers. And yeah, you do know how to square numbers, but this is a binomial here. This isn't just a number, okay? We have to think of our order of operations. Our order of operations says to add, because we have, well, do parentheses first. So that means we have to add what's inside before we can do this exponent. So if you're trying to do the exponent to both of these first, you're going to be wrong. And so here's what I'm guessing most students would say here, right? Ooh, I know what it is. It's x squared plus 25. Because they're thinking, okay, well, x squared, x times x is x squared, and 5 times 5 is 25. The problem is that is incorrect. And again, it's because we are not doing our order of operations correctly when we try and square that, okay? So let's go ahead and do this the right way. Do not fall into this particular trap that you see on the screen right now. This is a common mistake. When you see a squared, you cannot just square what's inside and call it done. What you have to do is expand the binomial. What does it mean to square an expression? So if I were to say 5 squared or 7 squared or negative 2 squared, what it means is that we are multiplying that term or that number or that value by itself. So 5 squared is 5 times 5. You might go, well, I know that 5 times 5 is 25. That's why I put 25. Yeah, I know, but we are not just squaring the 5 and the x separately here. We're squaring the entire parentheses, okay? So what this means actually is that x plus 5 squared turns into x plus 5 times x plus 5, okay? So you're multiplying whatever is inside the parentheses by itself. So we would write this actually as x plus 5 times x plus 5. This is the correct way of doing this, okay? And I would really think it's a good idea for you guys to write down the wrong way and cross it out so that when you come down to studying your notes and reviewing for a test, you realize this is wrong, okay? and then write the correct way underneath it. So here we have x plus 5 squared turns into x plus 5 times x plus 5. Now we know how to do this now. We know how to multiply two binomials. So we can expand that. I'll go ahead and do that on my paper here. And I don't really want to make this any bigger. So we're going to write this as x plus 5, let's see, times x plus 5. We're going to rewrite that as x times x plus 5, the first term times the second binomial, plus the second term, so plus 5, times the second binomial. And then we'll distribute those, and we end up with x squared plus 5x. And then we'll distribute the 5, so we get plus 5x plus 25. Then we'll combine our like terms, so we end up with x squared plus 10x plus 25. That is the correct answer there, okay? X squared plus 10x plus 25. So don't be lazy. Like I said here, do not be lazy. Don't just square each of these numbers or these values. Make sure you are expanding the parentheses so it's x plus 5 times x plus 5. So if it were to say this, x plus 5 cubed, right? We might do a problem like this later on. This really means x plus 5 times x plus 5 times x plus 5. Okay? And then we'll talk about how to do that later, but just know that you have to expand it out. All right? Let's go ahead and take a look at some practice problems now that you know what that is about. I want you to go ahead and try these. Again, pause the video. If you would like, pause the video, do number 4 and 5, and then come back and compare your answers. And then watch or do 6 and 7 on your own, and then come back and compare those. And then do 8 and 9, and then come back and compare those. All right, for number 4, we have x minus 8 squared. So did you expand that? Did you say x minus 8 times x minus 8? And if you did, then you're on the right track. From here, we will rewrite that. So it'll say x times x minus 8 minus 8 times x minus 8. And then we'll distribute those. So we end up with x squared minus 8x, and then minus 8x plus 64. Then we'll combine our like terms, and we end up with x squared minus 16x plus 64. And so that is our answer for number 4. For number 5, I'll put that to the side, just like I have on the notes there. We have x plus 8 times x minus 8. Now notice that this is very similar to what we had when we expanded here. The difference is that we have a plus sign here and a minus sign. These two are different signs. This is actually called a difference of squares. And you'll see what happens when we do this. We're going to go ahead and expand this. So x times x minus 8 plus 8 times x minus 8. We distribute the x, so we get x squared minus 8x. We distribute the positive 8x, so we end up with positive 8x minus 64. And then when we go to combine like terms in this case, we see that the negative 8x and the 8x cancel each other out. And so you're left with x squared minus 16 for number 5. So that one's a different one. These are two different cases. These are special cases. This is what we call squaring a binomial, and this is multiplying a difference of squares. Okay? So if you haven't done so yet, do number 6 and 7 on your own, and then come back and see how you compared. Number 6, we have x plus 13 squared. That should expand to x plus 13 times x plus 13. And then I'm going to just show you the answer here. You can expand it if you would like, and you should, but just for sake of time, you should have gotten x squared plus 26x plus 169 as a final answer for number 6. Okay? If you didn't get that and you're stuck on what you got wrong, please make sure you reach out to me and ask for help. Number 7, we have x minus 13 times x plus 13. Again, that looks very similar to the one above. It's just 13s instead of 8s. I'll go ahead and do this one. X times x plus 13, and then minus 13 times x plus 13. And then we'll go ahead and distribute, so we end up with x squared plus 13x. And then here we end up with negative 13x minus 169. And then combine like terms, and what do we notice? The 13x and the negative 13x cancel out. So we're left with x squared minus 169 for number 7. Okay, and again, if you haven't done number 8 and number 9, please do those before you watch me do them. For number 8, we have 3x minus 1 squared. And I'm going to go ahead and do this one. We're going to expand it, 3x minus 1 times 3x minus 1. The reason I'm going to do this is because we have a coefficient in front of the x. That might be something that's a little bit more difficult. So we're going to expand this to say 3x times 3x minus 1, and then minus 1 times 3x minus 1. Again, this 3x is the first term in the binomial. This negative 1 is the second term in the binomial. And then we rewrote the whole second binomial twice. Okay? Then we'll distribute. So 3x times 3x is 9x squared. And then 3x times negative 1 is negative 3x. Then the negative 1 times the 3x is negative 3x. And then the negative 1 times the negative 1 is positive 1. Combining like terms, the negative 3x and the negative 3x go together. Well, what is negative 3 minus 3? That would be negative 6x. And so we get 9x squared minus 6x plus 1. All right, for number 9, we have a 3x minus 1 and a 3x plus 1. And then I'm not going to show the work on this one. It's going to look very similar to the previous ones before. We're going to expand it and do all that work. But you should have gotten 9x squared minus 1 as a final answer. Okay? And again, if you didn't get that correct, please make sure you're asking for help on that. But hopefully with all that practice, you're feeling pretty confident. Okay? So there is a bunch of good examples here. And so with that said, let's go ahead and go on to the next thing. Actually, before we do that, let me compare my answers to make sure I did all of those right. And I didn't. Oh my goodness, I didn't do this right. Oh no. Let's go back up to number 5 real fast. How did I screw that up? 8, right here, the last one. When I distributed the 8 times the negative 8, what in the world was I doing? We're multiplying here. 8 times negative 8 is negative 64, not negative 16. So that doesn't make sense. We end up with x squared minus 64. All right, so that's that. And then keep going here, making sure I did everything else right, because I obviously screwed that up. That one looks good. 9x squared minus 6x plus 1, that looks good. And then the 9x minus 1 looks good. All right, so that's a good deal there. All right. Let me go back just for a second. So I want you to recognize that there are some patterns that we can observe here. I'm not really concerned about knowing those patterns yet. What I really want you to pay attention to is that when you are squaring a binomial, you have to expand it first, just like I did here. We have to rewrite this at x minus 8 times x minus 8, x plus 13 times x plus 13, and so on, okay? Now let's talk about more polynomials. So far, the only examples that we've dealt with in terms of multiplying have been dealing with binomials, remember, meaning 2 terms. But let's expand that to talk about trinomials maybe, or more higher degree polynomials. So here's an example. You're going to put this on the right-hand side. It says simplify x plus 2 times x squared plus 2x plus 3. Well, this is a binomial times a trinomial, okay? So I'm going to go ahead and do this here. It should be on the right-hand side, and it's an example, okay? X plus 2 times x squared plus 2x plus 3. Okay, so when I expand this, I'm going to do it the same way that I did on the prior problems. I'm going to break the first binomial apart. So I'm going to write x, and then I'm going to multiply that by the whole second term times x squared plus 2x plus 3. And then I'm going to write the second term in the first binomial. So it'll be plus 2 times x squared plus 2x plus 3. And then we'll just distribute like we did before. We're going to distribute the x into all 3 of these terms this time, not just 2, but 3. X times x squared is x cubed. X times 2x is 2x squared. And x times 3 is 3x. Then we'll go ahead and multiply the 2 into the second trinomial. 2 times x squared is 2x squared. 2 times 2x is 4x. And 2 times 3 is 6. From there, we're going to combine like terms. I only have one term with an x cubed in it, so I'll just carry that down. But notice I have a 2x squared and a 2x squared here. And so that turns into 4x squared when I combine those. And then I also have a 3x and a 4x, which gives me a 7x. And then the 6 is just a constant at the end. There's no other constants combined in this case. So that is the simplified form. And again, I'm going to check my work to make sure I did that right. That looks good. Okay, so that's an example of how to multiply polynomials, not just binomials, but any polynomials. With that said, here's a couple practice problems for you. I want you to go ahead and try them on the left-hand side, the left-hand page of your notes. Actually, there's 4 problems here. They're not all necessarily higher level ones, but go ahead and give these a try. And if you get stuck, that's okay. Just watch the video and watch how I do it. And hopefully that helps you out. And if not, make sure you're asking questions when we meet again, okay? For number 1 here, we've got x times x plus 5. Now this one's pretty straightforward. This is not even multiplying polynomials necessarily. We're just going to distribute the x in there because that's a monomial. That's just one term. So x times x is x squared and x times 5 is 5x. And we are done with number 1. Okay. For number 2, we have something that says 3x minus 7 times 4x squared plus 4x minus 3. Well, we're going to go ahead and expand that like we did before. That's going to say 3x times 4x squared plus 4x minus 3. And then minus 7 times 4x squared plus 4x minus 3. And then we'll go ahead and distribute. So 3x times 4x squared is 12x cubed. And then the 3x times 4x is going to be 12x squared. And then the 3x times the negative 3 is going to be negative 9x. Okay? Then we'll distribute the next term, the negative 7. Negative 7 times 4x squared is negative 28x squared. And then negative 7 times 4x is going to be negative 28x. And then the negative 7 times the negative 3 is going to be positive 21. Combining like terms now, we only have one term with an x cubed, so that's 12x cubed. We have 12x squared, negative 28x squared, so that's going to be negative 16x squared. And then we have negative 9x and negative 28x, which is negative 37x, and then the constant at the end, so plus 21. So that is our answer for number 2. I'm going to go ahead and check my answers on those two to make sure I'm good before we move on to the next thing. That looks good to me. Okay, let's go ahead and take a look at, running out of room here on my paper. Let's go ahead and take a look at number 3. I like number 3. Number 3 is multiplying 3 different binomials. 3 different binomials, that's interesting. Well, in this case, what we have to do is, let me give you another example just off to the side here. If I were to say 2 times 3 times 4, how would you multiply those? Well, you would have to multiply 2 terms first, so you'd end up with 6, and then you'd take that and multiply it by the last term. So we're going to do exactly that. We're going to multiply the first 2 guys together first. So I'm going to go ahead and expand this. It's going to say x times 3x minus 2 minus 1 times 3x minus 2. And so we're just multiplying the 2 binomials right now, okay? So when I distribute that, I end up with 3x squared minus 2x, and then distribute the negative 1, we end up with negative 3x, and then plus 2. We'll combine those, so we end up with 3x squared minus 5x plus 2. Now that is the multiplication of the first 2 things, but then we have to take that and multiply it by the last term, by the x plus 4, okay? Now, this looks a little bit different because we have a trinomial here. Oops, kind of cutting things off here. We have a trinomial here first instead of a binomial in the previous problems, okay? So actually what we're going to break this into is 3 different expressions. It'll say 3x squared times x plus 4 minus 5x times x plus 4, and then plus 2 times x plus 4. And then from there, we'll distribute each of those terms into the x plus 4s. And so we end up with 3x cubed plus 12x squared, that's the first one, and then minus 5x squared minus 20x, that's the second one, that's a squared there, and then plus 2x plus 8, and that's the last one. From here, we're going to combine like terms. The 3x cubed is all by himself. And then we have the 12x squared and the negative 5x squared. That's going to be plus 7x squared. And then the negative 20x and the 2x becomes negative 18x and then plus 8. And so there we have our answer. And we're going to compare that to the board, and it looks good to me. All right, one more problem to go for today. And this is exactly the type of problem I was talking about earlier. We have x minus 2 cubed. Okay, what does that mean? Well, that means x minus 2 times x minus 2 times x minus 2. And so we're going to focus on the first ones, the first 2 binomials. We'll expand that to say x times x minus 2 minus 2 times x minus 2. Distribute that, so we end up with x squared minus 2x, and then minus 2x, and then plus 4. We'll combine like terms, so we end up with x squared minus 4x plus 4. And now we just multiplied just these first 2 terms here. Now we have to bring down and multiply the last term to that. So we'll go ahead and expand that out. That's going to say x squared times x minus 2 minus 4x times x minus 2, and then plus 4 times x minus 2. Again, we've got 3 terms here, so we should have 3 sets of multiplication, okay? And then we'll go ahead and distribute all that. X squared times x is x cubed. X squared times negative 2 is negative 2x squared. Negative 4x times x is negative 4x squared. Negative 4 times negative 2 is positive 8x. And then 4 times x is 4x. And 4 times negative 2 is negative 8. Combining like terms now, we got the x squareds. So we would say x cubed minus 6x squared. Then we have the 8x and the 4x. So that's going to be plus 12x. And then the constant at the end. All right. And I'll compare my answers there. We got x squared minus 6x squared plus 12x minus 8. And it looks like we did it all correct. All right, so that wraps up this lesson in multiplying special cases. Really the main point of this lesson is, do you know how to square a binomial? You need to know how to expand it before you multiply. You do not just square both of those. Going back to, let me get back to that page. Going back to this page right here is the most important part of today's notes, okay? So go ahead and write your summaries and submit your notes so that I can grade them. If you have any questions, you can comment below, or you can email me, or you can wait till the Zoom meeting, or you can log into the tutoring. Whatever it takes for you to be successful, please engage and do your best. Until next time, I will see you around.